Okay, cool. Hello, everyone. Welcome to our last, final, fifth workshop of this series of workshops that we've had before the hackathon on November 1st and 2nd. While we wait for the last few people to trickle in, I think maybe if you want to drop your favorite movie or TV show in the chat, or both, if you like watching both types of media. Um, I'd love some recommendations.
Hmm.
I have been watching this K-drama series called Any Genre is Fine. Whatever is your favorite, your comfort movie show. I've been watching this K-drama series called Tempest, and it is very gripping. If anyone wants a thriller, I will say there is murder involved. Yellow Jackets is such a good show. I love that show so much. That is a really good show. Gonna wait for maybe half a more minute. Um, Friends is also a good show. Nice. Okay. Only Murders in the Building, Pirates of the Caribbean, all fantastic shows. Like, yep, in movies. Remote droppers is such a good phrase. I've not heard someone use the phrase in a really long time. But wow. Awesome. Okay, cool. So like I said earlier, this is the last prep workshop before we meet you at the hackathon. It is going to be on November 1st and 2nd, and we're gonna have core hours. We're gonna cover the core hours later in the slides and confirm that you got the email, but in case some of you need to drop off after the first hour today, if you have not received an email from us asking you to confirm your RSVP, please let us know or reach out to us so that we ensure that we have your participation and confirmation for coming to the hackathon. If you're new here, Fair Forward is a workshop and hack series. We are at the very tail end of the workshop part of it, and we are going to have a hackathon. Good thing is all the workshops are recorded, and slides are posted on our website, which you can find at biodatasage.com. And this event is primarily for BIPOC students. So today's focus is data visualization, like the topic said. We are going to be doing it in R, and we'll sort of have a 2-hour chunk. So the first hour is going to focus on the core foundations that you need for data viz. And we recognize that some folks weren't available or free. So we're going to be doing more plot types. And then if we have time, talk about data storytelling and themes in ggplot. But you should be able to watch the recording and catch up very seamlessly and easily if you do end up missing the second half. But we hope that most of you can stay and stick with us throughout the workshop. So just as a recall of how our studio looks like, on your pane, on the left-hand side is where you have your notebook open. So you have your notes and you have your code below that. On the right is your environment pane. So you have objects, your data, any variables that you store, anything that you put into an object shows up here. At the bottom left is where you have your results. So if you want to use R as a calculator, if you want to print something, that shows up at the very bottom left of it. And in the bottom right is your written files. So you have your notebook, which is a .rmd extension, any pictures you use for your project, your data sets, anything you want to bring into your project. So your inputs, data sets, as well as your outputs. So if you want to save a plot that you create, a PDF or a PNG, any sort of file will be stored in this section of your RStudio. So just a recap, if RStudio is new to you. And a little introduction about ggplot. So we can kind of think of it like cake. I will credit this entire slide to Tanya Shapiro, who is a fantastic data viz person in the field. And she posts a lot of really good tips and advice on LinkedIn if you're ever curious or you want to build on your data viz skills. But ggplot is essentially a really nicely layered, beautifully stacked cake. So you start off with the base, which is something to hold your cake. And you don't have to remember all of this. I'll be going through it again as we go into the actual project. But once you have your base, you're going to start with ingredients or the recipe to make the cake that needs to be held in the base. And then you're going to start actually figuring out what you want in the cake, which are layers or your content of the cake. And then the very end is both tweaking your cake. So it's like scales, your axes, whatever you want to customize in your cake. And then at the very end is your decor and what do you want your cake to look like from the outside. I realize I kept saying cake a lot, but I obviously meant graph. I am now just thinking about cake and I'm clearly hungry. So hopefully this is like a good analogy to start. And it'll sort of help if you're completely new to data viz to keep this image in mind, just so that it helps you like build out a plot. And you'll see how this plays out in our code as we start with our project. So I'm going to open up my Posit Cloud window. Are you able to see my window on Zoom?
Yep.
Okay, great. Cool. So if you want to drop the workspace link, Alyssa, on the chat.
Done.
Thank you. So if you are completely new with us and this is your first workshop with us, if you do not have a Posit Cloud account, you want to create one with the email that you use. But otherwise, we have created oops, that went back. That's weird. We have created a Posit Cloud account together, so I'm going to open up this link here. So if you're already logged in, the first thing it should do is ask you if you want to join the space. You want to click on yes. And it should open up into this fair forward space. If you click on content, it's going to give you two different notebooks. This was from a previous workshop that we did. So for this series, if you missed out on the R programming workshop, this should show up as an empty notebook. And then today we're going to be looking at data visualization in R. Before I click on the project, I also want to remind us that on the left-hand side of your Posit Cloud space, you have access to a bunch of resources and information that you can access whenever you need. So you have the guide, you also have what's new and recipes, which are basically things to build in R, but also this really cool feature called cheat sheets. And this is sort of like a life hack for me personally when I forget how to do something data viz wise or any other thing wise. And when you click on it, it sort of brings you to major packages in R. And if you're curious, ggplot is all the way at the bottom of this page. And it kind of opens up into a PDF. So visually, this is sort of like how functions can be used and how you can build out a template to create the plot you need. So just in case if this is helpful throughout today's workshop or after and for the hackathon, you can always go back and refer to the cheat sheet. So I'm going to click on this project. That's going to start deploying. If anyone hasn't gotten into the Posit Cloud space, please let us know in the chat. And if you have started clicking on the project and deploying it, if you could give me a thumbs up, that would be great. Or raise your hand, that would be great. See a few. Thumbs ups. Um, I think we have the last few people to go in, so I'm gonna give them maybe 30 more seconds. Cool, cool, cool. Okay, cool. I think most of us are in. If you're still stuck and I didn't catch you, please let us know in the chat and Alyssa can help you troubleshoot as I start with the notebook. So you're going to click this notebook called dataviz.rmd. And again, if you are new to this, you want to click to visual instead of source. This is going to give you what looks like ideally like a Word document or a PDF so that it looks a little neater. I'm gonna pull this down so we have some space. So this is the page you should be landing at, and this is your art notebook. So again, welcome. If you have not been introduced to this data set, today we'll be using CDC's Youth Risk Behavior Surveillance System. It looks specifically at high school students and measures a ton of different data metrics. So broadly, student demographics, youth health behaviors, substance use, student experiences, and you're able to directly download this from the CDC website without having to have a CSV. But you'll notice that we did download it into our project space just in case someone runs into an error reading the file. Or if we're not able to access it in the future, you will still have this in your project space that you can export out for your own practice. So there are two files today. YRBS full is your entire data set, and we'll see that once we read it in. That's going to be the original data that we use. And today we are primarily going to be using this YRBS mutate file, which we did use and create in our previous R workshop. So this is new to you. I will also be going over like what we sort of did as a high level overview. That'll help you give you a good idea of what we did. So to recap, an R package is a collection of our functions, documentation, and data for a very specific purpose. It is usually saved in something called a library, and it can be turned on and off because you just want to bring in what you need and not necessarily all of the packages that ever exist, which honestly is probably a lot. I don't even know the number of packages that are on CRAN at the moment, but you only want the libraries that you need and you want to turn on only the ones that you want. And so normally when you work with a new package for the first time, you're going to install it using install.packages, which is the function, and you're going to name the function that the package that you need. And then you're going to use the function library to turn it on. And one other way to do it is to go in here and click on packages and scroll down to the package you want and click on this little checkbox, and that's going to turn on a package for you. So the first thing we're going to do is turn on the tidyverse package. So right here, I'm using the library function. So library tidyverse is what we want. So if you click on this green arrow, it runs the chunk for you, and you can see that it ran and turned on the library. And if you go here and scroll down to tidyverse, you'd be able to see that it turned on over here. So after that, we want to read in our data set. So right now, just so that we can look at it, I'm going to also give you a preview of what the full data set looks like. You can see that these are original survey questions from the data set, and there's about, I think 250 columns in the data set, and basically the entire data from CDC imported. But today that is not what we want. Today we want to use the specifically modified and edited data set. So as a recap, in the second part of our Introduction to R workshop, we used the 6 major functions in Tidyverse to sort of select the columns that we want to work with today and modify it and create columns that are going to be useful for us in today's analysis. So if you want to look at that script and if you want to go over the steps that we followed for that, you can please go watch the recording on the website that's been posted and also on our Slack channel. So the first thing we want to do is bring in this data set and read it. So the function that you need for reading a CSV is read_CSV and then the name of the file. Another way to do it would be to click on the file in your files pane and then click on import dataset. And it will give you a preview of the data, but you could also bring it in and it gives you a little code chunk that you can copy and paste. So you could also rename the file, whatever you want to call it. And you have the code preview here that you can copy using this symbol. So I'm going to use the function to call this, and reading the data set, you can see that you have YRBS_mutate pop up in your data set. And if you click on this blue arrow, it will show you sort of what the structure of the data set is, what the column names are in the data set. You can see that we have age, sex, height and feet, which was a column that we created. We have weight in pounds, a column called sexual identity, and then negative mental health. So the package that we're going to use today for data visualization is ggplot, which stands for Grammar of Graphics, so the 2 Gs. It is one of the most common packages used in building Viz. There are plenty of other data viz packages in R, but this is the more predominant one. And my favorite one, I will say. I don't know if it's Alyssa's favorite, but definitely mine. We are very, very team ggplot. I see Alyssa like throwing hands. We love the package. It is very intuitive once you learn the fundamentals of it, and it sort of feels like very natural once you start getting the hang of how the language behind ggplot works. So the idea, like I said, is it's sort of like a cake and it's an object. So the first thing you're going to need is what goes at the base of the cake. So you're talking about your data set or your data frame that you're working with. And the second thing you're going to be looking at is your aesthetic mappings, for short AES. And this sort of tells you what is going to be on your x-axis and your y-axis and what is going to be plotted on the actual graph. So what shape do you want it to take? What size do you want it to take? What colors do you want to adjust the transparency? If it's a line, do you want it to be dashed? So on and so forth. So anything that you want to visually alter specific to the plot that you're building, you're going to throw this inside something called AES. We're going to see how that works in a very quick minute. And then the third thing that you need to know is the geometric object itself. So after you've built out sort of the lay of the land for your plot, the second thing is what kind of plot do you want? And this is usually determined by your variable types and what you're trying to show. So let's very quickly look at the difference between a discrete variable and a continuous variable. So discrete variable has very clear spaces between values, whereas a continuous data falls on a continuous sequence. You can count discrete data, so number of pens you have with you, or number of pencils you hold, number of times you ate cake today. But continuous data, I'm gonna make this whole workshop cake themed, and I apologize for the future me for doing that. But for continuous data, you're not able to count not enough times. You're not able to count the data that you have if it is continuous. So for example, if you look at the the specific length of time it took for you to go to the grocery store, and it falls in like a continuous series, you're not going to be able to count that, versus you can count the number of times you went to the grocery store. And you're not going to be able to measure discrete data, but you are going to be able to measure continuous data. So for example, the number of cats in a park, your shoe size, number of students in this workshop or in a classroom, and then continuous data is temperature at the park, your foot size instead of your shoe size, and the age of the students. Continuous data has an infinite number of possible values. So you can be 1.11, 1.12, 1.13, and I can keep like dividing that into smaller and smaller pieces. Versus discrete values is a finite number of possible values. So you can eat one cake, you can eat two cakes. Technically, you can eat 1.5, but you're not going to tell someone you had 1.635 amount of cake ever. If you do that, I am very curious to see how you measure the 1.635 amount of cake. So that essentially is the overall difference between a discrete and continuous variable. So below in your notebook as well, you should be able to see this image. When you have a discrete variable, usually differentiating it by color works in a way that you have distinct colors for each different value that you're measuring. And for continuous, it's a gradient because it goes from one end to another and not sort of in like very, very concrete steps or intervals. For discrete data, you can also differentiate it by size. So same with continuous data. You can differentiate it by shape as well for discrete data, but you're not going to be able to do the same for continuous, because once you start doing that, it's going to create so many different types of shapes, and it's not going to be able to tell you what the actual difference is. So I'm going to pause here and ask if we have any questions or this sort of makes sense. If we need any more explanation between a discrete and continuous variable, because this is going to be sort of the foundation of you choosing what kind of plot you want to look at, and also being able to like customize your plot in a way that makes sense and pretty. So two things at once. Okay. I think we seem pretty clear. So, everyone's very excited to start actually doing plots and looking at graphs. So let's start with the bar plot. Say we want to look at how many patients in this data set identify with each category. So if sex is a single discrete variable, in this data set, we have male and female. So once again, you can, it is only two possible values. It is not anywhere in between. So bar plot is suitable. We're going to use the ggplot function on the YRBS mutate object. So how a general plot function works with ggplot is that you're going to open it up with the ggplot function. The sort of tells R that you are building a plot and give it like an empty space to build a plot. And the second thing you're going to do is define the data set or object that you're working with. So today we are looking at YRBS_mutate, which is our data set. And now that we have established that we are using this data set and we're building a plot, the next thing we want to tell it is the aesthetics mapping. So AES is the shorthand of aesthetic, and you're going to use X equal to sex because we are trying to look at the distribution of sex as a variable in the data set. So this is going to be inside ggplot. And when you do this, just this section of the code are basically will build a plot and have sex on the x-axis. And this time we're going to run a bar plot because that's the type of chart we're interested in. So the function is geom, short for geometric object, and then underscore and the type of bar. So if I run this chunk, you can see that it is a bar plot. On the x-axis, we have sex as a variable, and we can see females and males are distributed almost equally in the data set, but not quite. We do have more males. And I will say, just as like an overall addition, if you start typing in geom underscore, R will populate the different types of plots for you, and you're able to scroll down and see what you want to use if you're not sure. And it also give you not only a description, but like not only a title, but also a description and what it does. Delete that. Cool. So now we are going to try to plot a histogram. What if we wanted to look at height in feet specifically, and how that is distributed in the data set? So again, we are going to use the same ggplot function and then use aesthetics to map it out and then add the type of plot. So if you want to try that, right now,
Do you want to go through sort of like the structure of the code again? Like what they need to
yes.
do first, then next kind of thing?
Yeah. So I'm going to use the bar plot as an example. So the first thing we did was use the function ggplot. So this basically creates the axis. So if you run that, you can see that that is just a blank plot. And then the second thing you're going to do is define what data frame you're working with. So if you put ggplot, YRBS mutate, and run that, that is still not going to add anything. You've just now told it that that's the data frame you want to look at. If the next thing we want to do is tell it what kind of ingredients we want to use. So inside the aesthetics mapping, you want to define X equal to sex, because that is what we're specifically looking at. So now it has taken the data, it has put a variable on the axis, and it has divided it by unique columns. But we have still not told it what type of plot we need. So we're going to select a plus, not a comma this time, because you're adding a layer on your cake. And then select the type of function we want. So if you type in geom underscore bar, so we're looking at a bar plot, it will now add a bar plot to the foundation that you just built. Alyssa also dropped the pseudocode for general plots and how you can sort of structure your code. So for a histogram, you would also do the same. I'm just going to drop in Alyssa's pseudocode here first. You have ggplot, data, and then your aesthetics. And this is going to be your variable. And then put in geom, and then your plot type. I'll set up. So if you want to try filling that out in the next few minutes, and raise your hand once you've gotten it so we know who is done. Cool. So I can walk us through um, how to go over doing a histogram. So, like the pseudocode says, we're going to start with the function ggplot, and we're going to replace the word data with the actual data frame we're looking at. So we are using YRBS mutate. And this is the foundation of the plot. The next thing we are going to tell R is to choose the x-axis. So we're going to replace variable with height underscore feet, because that's what we want to look at. We type in height underscore feet. So this is going to give you the foundation of the thing. So I'm gonna just show you what that looks like. So if I run that, you can see that it's an empty plot and you have height on your x-axis and the range of it, but not the actual plot or the graph. So the next thing we want to do is geom underscore plot type. So if you're unsure of what you want, if you type in H, you can see the different options and you can see that there is a histogram in the geom function option. So if you click on that, it's going to auto-populate it for you. And this is going to be the structure of this code. So if I run this, you can see that this is the distribution of the height in the data set. You can see that it starts at 4 and goes a little above 6, and we sort of see it peak in between 5.5-ish. So you should be seeing this graph. Could you raise your hand if you're able to see this plot on your Posit Cloud space? So we know that everyone's able to follow through. Okay. Again, if you are stuck and if you need help at any point in the workshop, please let Alyssa know, and she is here to help you troubleshoot and fix what's going on. So you usually see an information bubble that pops up here, and the information bubble is not popping up today. But by default, the histogram will break the data into 30 bins. We can either bin the data in a set number of bins, so the rectangles that you see in your window, or a set number of values in each bin. So the default of 30 bins may not actually be the best way to visualize our data. As ggplot suggests, this can make histograms very frustrating because you need for it to look like it actually makes sense and for you to be able to interpret it a little better. So let's fix that, and let's actually specify that we want to bin the data by 0.25 feet increments by adding this parameter. So whenever you specify anything in your plot, you want to add it inside the call to the actual function. It'll add some pseudocode again, but we want to specify and define a specific bin width to be using in our geom histogram. So you have ggplot as your function, and then this is going to be your data object, and then you are going to define your aesthetics. This is going to be your x equal to your variable, and then you're going to add a layer. So this is your foundation of your graph, and then you're going to use geom underscore histogram, which is the function we just used, and then specify the bin width that you want to use. So you're going to do that here. That would be parameter equal to value. So if we want to try replacing that, if you're able to change the bin width, you can raise your hand again so that we know once folks have gotten the new plot. Remember that we are still looking at the same data set and we are still looking at the same variable, which is height, specifically in feet. And the only thing we're changing is adding the width of the bins for geom histogram to use. One more minute, maybe. Okay, so your data is going to be YRBS mutate again. And then your aesthetics is going to be X equal to height in feet, because that's what we are interested in. And inside your geom histogram, we are going to define bin width, which is our parameter, and we're going to tell it 0.25. So when you run this chunk, you'll see that the width has changed and it is now giving you a little more thicker blocks or thicker chunks. If you are able to reach this point and run it and also include bin width, if you could raise your hand again, just so we know that everyone's able to follow through, that would be awesome. Okay, cool. The third type of plot that we're going to look at today is a box plot. So let's take a look at two different kinds of variables now. So far we looked at the distribution of sex and the distribution of height in our data set. But if we wanted to look at both and use height on the y-axis and sex on the x-axis, we could use a box plot, sorry, to look at how it's differentially distributed. So once again, I can sort of guide us with the pseudocode, and then we can all try to do the graph. So you're going to start off with your ggplot and then tell it which data you want to look at. So data, and then your aesthetics mapping. So essentially your ingredients. So you're going to tell it x equal to variable, and then y equal to variable that you want to look at. So this is, oops, sorry, I ran that by mistake, and this is not running because we do not have an object called data. So after you do this, you're going to add a layer to your cake once you have the basics, and that is going to be using geom underscore boxplot as your function. If we want to try filling in what needs to go on the graph, and raise your hands once we have it. Give it one more minute. Okay, so data again here, the object that we are using is wire BS underscore mutate, which is the data set. And inside aesthetics, we are going to tell our what we want on our X and Y. So for our X here, we want to look at sex, and then for Y, we want to look at height and feet. And we have defined what type of plot already. So it's going to be using geom underscore box plot. And when we run that, you can see the distribution of height divided by subcategory of sex. So you can see that the average or the mean of males are higher in height than females, but you can see that there are larger outliers in the male students in this data set compared to the female students in the data set. So if everyone's able to see this plot and this graph on their workspace, if you want to raise your hand so we know that you're able to follow through. Yes, that happens a lot to me too. I also reverse my X and Y sometimes. And it sort of looks like horizontal. That happens, especially when you're first starting out, but it's a very quick fix. Okay, cool. So before we do the last type of plot, do we have any other questions that we have so far about how the overall structure of a ggplot function works, or how to build out a plot in ggplot? Okay, cool. So for the last type of plot we do before the bonus bits, we are looking at a scatter plot. So we're interested in the relationship between two different types of continuous variables. So you want to look at height versus the weight. And we want to do this looking at a scatter plot specifically. So I'm going to give us the pseudocode to get us started, and then we could all try building it out. So ggplot is the function we want, and then data set you are interested in. And then inside aesthetics, you once again have two variables. So x equal to variable, y equal to variable, and it's going to be your foundation. The first layer you build is going to be geom, and then this is going to be the plot type you are interested in. Note that this is also in the notes part of your notebook. For a scatter plot, we specifically use the function geom underscore point and not geom underscore scatter, because it is actually just points on a graph, even though we call it scatter plot. So ensure that you are using that function to build out the scatter plot. If you want to try this out and give this an attempt and raise your hand once you have it. Maybe I'll give it one more minute. Mm. Okay, cool. So to replace these, once again, you have the ggplot function, and then you're going to define the data set you want to look at. So this is going to be YRBS mutate, and then your aesthetics call. So inside the aesthetics call, you're going to tell it what you want on your X and Y axis. So in this case, like Alyssa mentioned, you could reverse your X and Y direction, and it just would look a little different, but it would still be the graph you need. But over here, we want to use height on the x-axis and weight on the y-axis. And then your plot type here would be geom_point for scatter plot. So if you run that chunk, you'll be able to see that it gives you a scatter plot of weight on the y-axis and height on the y-axis. This generally looks like an upward trend, meaning higher value of height gives you a higher value of weight. Now, if you reverse this and just switch out the order, you can see what that looks like. So it's going to look like weight underscore pounds or LBS, and then if we do y equal to height in feet and run that, you can see that it's sort of just like tilted to the right or rotated. But it still gives you the same trend of if you have a larger value of height, you will have a larger value of weight, or vice versa. Like a smaller value of weight will give you a smaller value of height. We can also add color, size, and shape to this graph to sort of customize it and make it look like what we need. So if we wanted to add color and differentiate the color by our sex variable, so males and females would receive a different color, where would we sort of add it in this code block? You have geom_point as a guess. We have inside aesthetics as a guess. So first we can see what both of the answers give us. So if I put it under geom_point and define color equal to sex, you can see that it's looking for an object specifically called sex. So that's not what we need because we are modifying the visual aesthetics of the graph. Let's try putting this under aesthetics now. And if we run this, you can see that we have now colored the scatter plot by sex. So pretty distinctly, you can see that females fall on the left side of the chart, meaning lower height values, and more males towards the higher height values on this chart. So like Alyssa said on the chat, anytime we want to map data to a specific thing in the plot, it is going to be inside your aesthetics call. So inside this, behind whatever variable that you define to be on the graph. So now if we wanted to add size and differentiate the size by sexual identity, where would we do that? If we also want to drop the guess in the chat or unmute, either way. We have aesthetics as a guess, so let's try to see if we do that. What it looks like. Spelled that right. You can see that the size has sort of changed based on the responses for sexual identity. So that works. It's great. Awesome. We can also change the color, size, shape, and transparency of all points instead of assigning them to a specific variable. So we have linked this key that you can use for all the colors and say shapes. So I'm going to click on it so we can overall see it. And you can see that this is documentation for the function. And it sort of gives you the different options that you can use. So for line types, you have all of these options. For line width, so on and so forth. So you can also have different types of points in your scatter plot. And that will be defined based on the name of the shape. And you can also have color and fill to be different. So the outline of your point versus what color the point actually is. And you can also customize your text in your plot. And there's so many more ways that you can customize it. And this manual will sort of go over both the definition of the function, but also examples of how you can do this inside ggplot. So to go back in here, if we want to have all of our points to be large blue, and we want to add it to this scatter plot, where would we add it? If you want to guess again. So since we are specifically changing the scatter plot, and we want to change the look of it, we want to define the color here. If we put in color equal to blue, because you're telling that you want the whole plot to just be blue, if you click on the play button here, you can see that your entire chart just turned blue. Now, say we want all of these to have diamond shapes instead of circular points. Where would you throw the shape function? Yes, correct. That is also in geopoint. So one thing to note as I do this is that inside your functions, you're going to need a comma to start adding things. But between layers of ggplot, it's a plus sign and not a comma. Just keep that in mind. So this is going to be shape and then coat diamonds. And then if you want to run that, you can see that they're very tiny, but they are diamond looking shapes. So the next thing we want to do is increase the size. So we are also going to add this into geoplot. It's going to go in the next line and size, and you can play around with this to sort of see what it feels like. So let's start off with 0.1 and run the check. That became infinitely smaller and almost invisible, which is not what we want. So I'm going to increase that to maybe 0.4. It is still really tiny. If we do a size of 1, yep, still not big enough. If we increase it to 4, you can see that the diamonds are a lot more visible and they're blue, and the size has now been changed to 4. Now, if you want to change the transparency of your plots, you can use the parameter called alpha inside your plot function, and this sort of changes the transparency of your plots. So if you want to now try that in your code chunk, along with the color, shape, and size customizations, and raise your hand once you have a transparent or more transparent scatter plot. That would be awesome. So we're again just adding one more parameter to change here, and you're going to give it a value. So we're looking specifically at the transparency, which is called alpha in ggplot. Then you're going to give it a number to make it more transparent. So here in parameter, you're going to change that to alpha, and then your value is going to be 0.5. Just to play around with it. And you can see that some of them sort of became lighter. We can make this even more transparent. And so you can see that that became a lot more lighter in shade, and some are more concentrated. So you can see that there's like a more clearer trend in your scatter plot. Cool. So now if we want to go back to our relationship between height and weight, we want to now specifically look at a regression line. So far, we've looked at a scatter plot. We can sort of see with our eyes that there's a trend, but not so much like mathematically. So now we can add that inside another function called geom_smooth. So we have laid out the foundation of the graph. So we have ggplot, we have our data frame YRBS mutate, and we have told the plot that we want height on the x-axis and weight on the y-axis. And then we're telling it that we want a scatter plot. So if I run this, you're going to see a plain scatter plot. And now what we want to do is use geom_smooth as a function to run a regression. So I'm going to add another layer with a plus sign and call geom_smooth. And we are going to tell it a specific method. So we want to use a linear model for this case. So we're going to tell it method inside geom_smooth, and then to give it the words LM. And if I run this chunk, you can see that it creates a regression line based on the values in the data set. You can also go in and change the color of this line, the size of this line. So essentially everything that we did here, you could do again with as many layers as you create in ggplot and customize it however you want. So if we want to export this specific graph for a project or for your hackathon in November or whatever you want to use it for, we can use the ggsave function, and we can give it a file name. So if you use .png, it is going to write out the plot. If I run this, you can see that a new file popped up in your file pane on the bottom right, and this should open up as a PNG for you. And you can now include this in a report, a Word document, any other type of summary that you create. So I'm going to pause here before we head to our bonus bits of today's workshop and see if anyone had any questions, just as like an overall recap reminder overview for any sort of graph that you built using ggplot. You're going to start off with the function ggplot itself, and then you're going to tell it what data set you want to use. and then the aesthetics. This is going to give you the foundation and the very, very basic layer of your cake. So it's just the first sponge. And then you're going to tell it what you want your layers to have and what type of graphs. And that is always going to be geom underscore something. So whatever type of plots you're going to build, it'll start with geom underscore bar, geom underscore box plot, geom underscore histogram. And then you can keep adding layers. So you can also have two different types of graphs in one plot. You could also add a smooth line, which is what we did. And we can tell it specifically how we want to customize each of them. So if you want to change the color, size, and shape based on a specific value overall for the look of the plot, it is going to go inside the call for the type of graph. But if you want to use a variable and specify the exact aesthetics of the graph, it is going to go inside your AES call at the very beginning. So this is sort of the structure. I will pause for a few seconds to see if there's any questions, or if anyone has any thoughts or comments. Do you have a favorite type of graph, Alyssa?
I really like violin plots, but they're not as common. But probably scatter plot would be my second favorite, just because like it's you can customize it so much and do so many fun things with it. Um,
Yeah.
what about you, Padma?
Um, Sadly, I don't know that there's a direct way to do this with like the basic ggplot functions, but I do love a radial chart, just visually speaking. I like a radial chart. Just looks like a flower and it's like really cute, but also a really good way to show data
I think there is an add-on for ggplot to
for
make radial.
ggplot. Yeah. Cool. Okay. I do not see any questions, so we can get started on some bonus bits. So now that we sort of know how to build like the basics of a plot, and we've explored a couple of different types of plots, and you just heard me, mention other kinds of plots. So violin and radial are also different types of data vis that you can build. One very important part of data visualization is that you are telling a story and you need the story to be understandable by people that have no idea what your story is about. So you are technically, when you start building out data viz, you come from the point of view that you know the data set really well, but you should also keep in mind that it is going towards folks that have no idea what your data set is about, and they're going to use the viz to understand your data set, not use the data set to understand your viz. And so that's a very, very key reminder to keep in mind when you do any sort of storytelling or data viz. So we're going to start off by creating a bar plot that will count the number of students in each category in sexual identity. So we are going to use ggplot as a function, and then the dataset YRBS mutate. And then since we're counting sexual identity as the variable, that is going to go inside your aesthetic. And then we're going to use a simple bar plot because we want to look at a distribution. So if I run this chunk, you can see that we have the greatest number of straight students in this data set, and then followed by bisexual, gay or lesbian as the very least. So this sort of gives you the counts of students on the left and sexual identity as your x-axis. Now this is just a plain gray bar plot. Not necessarily boring because it still tells you a story, but we're now going to make some minor changes to sort of make it cleaner. So for example, the x-axis labels are close together, depending on your screen. It might even overlap. So we can add a theme function at the very end of your plot to tell it how exactly to adjust your x-axis based on the text. So this is going to use the theme function, and then we are going to use the call axis.text.x. So this is essentially taking the text on your x-axis, and we are going to specify the angle we want to use and the adjustment. And we're also going to leave the title of our x-axis to be blank, since it's pretty self-explanatory at this point. So you can see that if I run this chunk, it has sort of tilted 45 degrees anti-clockwise. It's still the same graph, still the same colors. The only thing that has changed is the spacing of these texts and the rotation of your different labels on your x-axis.
Hey, Padma,
Oh,
how
yes.
would you change your y-axis label to be a little bit more clear? Right now it just says count, but what are we counting? What could we add to make this a clearer plot?
Great question. We can specify what the count is about and sort of tell it, give it a title, give it a better title, and define that explicitly. So instead of axis.title.x, essentially whatever parameters are applicable for your x-axis, you can very easily copy it to your y-axis. So we're going to call axis.title.y, and you can see that R is going to also populate different options as you put in axis title. So if you just hover over Y, it sort of also gives you the explanation for how to use it. So axis.title.y, and then we can say count of students in YRBS 2023. So that's where the data is from. And then if you run that, you can see that I did not put it inside an element text. So we have called the function, but this doesn't specify that we're specifically editing the text element. So we can tell it to do that. Type in element, and this sort of tells you, along with the theme system, how to like choose what display you're changing. So if I go in element text, ooh, okay, it's a great conundrum. I think this changes the theme of your title and not so much the actual title of your graph. So if you wanted to use, yes, X labs and Y labs is a way to add on to your layers. So instead of using element X, since we're not rotating it or changing the actual theme of your thing, you can also add on another layer, sort of use YLab. One way to check what YLab does, since we've never talked about this function with X or YLab, you can put in question mark YLab, and this opens up the manual for the labels inside your RStudio. So you can see all the way at the bottom that it gives you examples of how to run it. So we did not touch labels or legends in our examples before. So just to quickly go over, just like your different types of plots, you can also give it very specific instructions on how you want your labels to appear. So in labs, you can tell it to use X or title or Y, and that sort of labels that specific thing that you're looking at. And then I believe the functions that Alyssa dropped, so YLab and XLab, would specifically just change the X-axis or the Y-axis. So use labs, and then we want to do Y equal to count of students in YRBS and run that. You can see that we have changed the title of the Y-axis. Cool. So now that we have seen the overall sort of breakdown and distribution of sexual identity. We could also add in another variable from the data set, which is the mental health question. So now we want to try creating a bar graph using the same data set. So your aesthetics would be still sexual identity in your x-axis. That is a discrete category. But now we are filling it in with your mental health question. So if I run just this part of the graph, you can see that it's blank because all we've told it is the type of data set we want to use, what we want on the x-axis. So it's correctly identifying the different types of variables. And it has ours now absorbed the information that you want to fill it with the mental health question, but it's still not giving you a plot because you haven't told it what kind of plot you want to look at. So we want to specify geom bar. If I just do that, you can see that it divides your bar charts into the different types of responses inside your mental health question. So this label you can see on the x-axis is sort of overlapping. So we don't want that. We want to go and fix the x-axis like what we just did above. So I'm going to copy paste this here. Just run this chunk. And you can see that it is now tilted the x-axis, so nothing's overlapping. It's adjusted itself. And you can see that the different types of mental health responses are also colored in each bar chart. You can see that there's a large like always response in both like gay or lesbian, bisexual, and some other way responses in the survey, and the least amount of always responses for negative mental health questions in the survey. So it would be helpful to filter out these missing values so that we can take a little a better look at how the mental health question is distributed. So we're going to go back and use our tidyverse functions that we covered in the second part of our R workshop. So the first thing you are going to do is call the dataset YRBS mutate. So this brings in the object, and then we're going to use the pipe function. So again, to recall, what the pipe function does is it takes in what you give it and sort of pushes it out. Think of it as a noodle maker, a funnel, whatever you like pouring things into. That's what a pipe function does. And then you're going to give it another filter. So we're giving it the object YRBS mutate, and we're going to use the function filter. And what we want to do is remove the missing values. So we're going to use the opposite, which is the exclamation point of if the variable is blank. So is.na is the function that tells you what is blank in your data set. And we're going to specify this specific question of negative mental health. And if I run just this to take a look, we can see that it has now filtered out the observations and there's no more missing values. And we can check this by using the count function. So if you go to YRBS mutate as your object and use count to look at the actual counts of your responses, you can see that there is no NAs or missing values in your updated data set. So after doing this, we also want to re-level our variable of negative mental health and sort of make more sense, because right now you see that you have always most of the time, and then it sort of jumps to never, which is not the ideal distribution we want to look at and make it a little more intuitive for our eyes to be able to see what that actually means. So we want to reorder it and make it a factor. So factor again is a type of data class, and you can sort of give it a specific order to follow in your data set. So we are going to use the function mutate to create a new column, and we are going to use the function fact underscore relevel, which you could use R again to sort of tell you what this function does. So reorder factor levels, and it also gives you examples again to sort of run over what this actually does. But we are going to tell it a very specific order of your responses. So you can see that you have always first, and then most of the time, sometimes, rarely, and never. So we're going down by the frequency of negative mental health observations in the data set. So we want to create that column, run that line, and then we're going to check the levels of these factors by using the levels function. So if I run that, you can see that it goes from always to never in a more sequential order than jumping around. So we can rerun the same bar plot code chunk from above. I'm just going to rerun this. And you can see that we've gotten rid of the missing values, so there's no more NAs in the plot. But also now we have ordered it in a way that we can look at the sequential of what's more at the very top in the always responses. And you can see that the highest amount of responses for never and negative mental health are in the heterosexual or straight group of students. So this is better, but there's still a lot of groups. There's about like 5 different colors going on and 5 different categories in your x-axis. So we want to group this a little bit to sort of make it a little more distinct. So the first thing we are going to do is filter out the not sure, because we do not know what the students answered. Going under bold assumption of what they would choose is not accurate and not advisable. So we want to filter those out. So again, we take our data frame, we want to pipe this with the pipe function. So that's basically move it to a function. And then we're calling the filter function. And then we're specifically saying not equal to, which the symbol is an exclamation point and an equal sign. And then we are using a not sure. And the second step we want to do is create a column. So we're going to use the pipe symbol again and use the mutate function. And this is going to let you create a column, and we're using the case when function. So I know we're talking a lot about different functions at the same time. Once again, just to recall, like you can go back into the help window at any point and check what a specific function does, or use the question mark and then the name of the function to sort of open up the manual. But case when essentially takes different scenarios and assigns values based on that scenario. So now in this circumstance, what we want to do is take sexual identity. If they responded with heterosexual straight, we're going to bin it into the heterosexual category. So no changes there. But if it's not that, if it's any of the other ones, so bisexual, gay or lesbian, or some or other way, we want to put it into LGBTQIA+ as a group. And so that is going to help us just have 2 different groups on the x-axis instead of 5. So we're going to run this code chunk, and you can see that in the very end, in the column identity new, it has only 2 different types of functions. And we can also use the count function again to do YRBS groups, a comma, and then identity new. And this sort of gives you the count. So this is like cutting the text off, but if you open up a new window, which it is not sharing right now. Oh no, just wanted to show this. You can see that the count opened up. Zoom is something I hope I figure out one day. The screen sharing properties of it all. So now we can revisit our plot by sort of looking at the group data instead of all 5 categories. So I'm going to replace the data set we want to look at with YRBS_groups, because that's what we called our object that we stored. It is going to be the exact same aesthetics and in terms of x-axis and in terms of fill. Nothing has changed. We still want to keep all of our theme settings the same, but use labs, so labeling as a function to call out what we're using in our fill. So if I run this chunk, you can see that it's labeling our legend, and it has now bucketed all of our responses into 2 different categories. So now the responses are a lot more visible, and you can see that there's a stark contrast in LGBTQIA students facing negative mental health a lot more than the heterosexual students in the data set. We can also further break this down by sex. So we can filter and plot both sexes in the data set separately, but this is going to become a lot of work and repetition in your code if it's more than two categories. So a really nice function in ggplot, and this is probably like my favorite thing to do in any kind of plot, is use the facet wrap function. It is actually so unlimited in terms of its capabilities and continues to blow my mind, but it automatically takes your plot and divides it into subplots based on the variable that you want to look at. And this has to be a discrete variable. So that's something to keep in mind. Plots can be organized however you want it to look like, so it's totally customizable in terms of the number of rows or the number of columns, or if you want to have a specific type of organization based on either year or like a rectangular layout, that is also possible. So what we're going to do is use the exact same plot from here and take the code chunk. And the only thing that has been added is this little plus sign, because this is still in ggplot world. It's still going to be a plus sign. There's no pipe, no comma. You're still adding a layer. So we've now added a lot of layers to our cake. It is very, very stacked. We are adding the like one more layer. So the facet wrap layer, and we want to tell it to automatically divide our plot. And we're going to take the variables inside the sex category in our data set. So if I run this chunk, you can see that it has now subcategories, female and male, and still has the same division of sexual identity at the bottom into the ones we've bucketed. And you can see that there are differences between queer females in the data set versus queer males, and straight females and straight males in the data set. And the difference is a lot more stark in the never having experienced negative mental health in straight males versus straight females. And there's also a likewise difference in queer males versus queer females in the data set. So we would want to run some statistical tests and things, but that is, I think, something that we have left for future exploration and more things to explore in your own time. I'm also going to go back and point out to the cheat sheet and sort of maybe like go over the layout of this. So the basics that we've covered for today is at the left side of this cheat sheet. It tells you that we are defining the data set and then giving its like aesthetic mappings, and then you're going to tell it its exact type of plot that you want it to do. And then any sort of facet wraps, any sort of theme customizations all come after the type of plots that you define. It also gives you recommendations for types of plots you want to look at, and also like an example of what the graph would look like. And you also have two variable graph types. So you have scatter plots, quantile plots, also your regression lines, so your smoothing. You could even add text to a plot instead of just like points in your data frame. You can also have box plots, bar charts, dot plots, violin plots that Alyssa mentioned. So that's going to be gm_violin. You could also look at continuous functions and distributions of your variables. So this cheat sheet really goes into like detail of how you can customize your specific plot. Okay, cool. I think I'm gonna maybe hand it to Alyssa for the next 30 minutes of the workshop.
I don't know that I need 30 minutes, but yes.
Okay,
Did want
whichever time you want.
Why, thank you. I just wanted to demo a couple of helper tools that I think would really help with like visualizing things, because it is really hard to sort of keep track of like all of the little nitty-gritty details, right? Like every plot needs sort of like the data the aesthetics and then the plot type itself. But then after that, like all of these like kind of, you know, like smaller tweaks to kind of make the plot look and feel a lot more readable can be like a little bit daunting, right? As you see, we've kind of added tweaking those things as sort of adds to our code complexity. So I just wanted to show a couple of tools that will make visualization hopefully a little bit more straightforward. Let me share my screen. All right, hopefully I'm sharing my screen.
Yes. Oh, yes, I can see your screen.
Excellent, okay. So for like this particular plot, let's take the last one actually. For this particular plot, let's say like I really don't like the gray grid background. You can sort of further mess around with the theme, but I'm gonna show you a tool that's part of the add-ins. So if you notice up here, there's this little button and it says add-ins. And if I click on it, I have already installed something called the ggplot theme assistant. And just a reminder, if you ever want to install packages, you can go to packages install and you could put in GG theme assistant. I've already done the installation for you, but in a new space, you would need to install this. But what's really neat is, so if I highlight my code here, and it is super important, you have to highlight it, otherwise this doesn't work. So if I highlight it, and then I click on add-ins, and I click on ggplot theme assistant, it will actually like open, oh, can you see the pop-up? Hopefully the pop-up is showing up.
Yes, I can see the pop-up.
Okay, cool. So it pops up this thing. It's like this nice little interactive window. It shows you your plot kind of on the top, a little squished here. But then basically it's got these different parts that you can play around with. So for instance, if I really don't like the background, I can change that. So for instance, like there is this fill, right? I can say I don't want that. I can say none. And it gets rid of that like gray grid background and that looks really nice now. I can also, for instance, go and say I would like to change, what else do I want to change? I can change like where the position of the legend is, right? Like if I instead wanted it on the left instead of the right, I can go ahead and swap the position of that. I can also do things like change the titles here. So for instance, it says identity new here, which is maybe not so great. So we can, change that to just identity. Oops, if I could spell, that would be great. You can also change things like the actual like text type if you really want to. You can change the size of the font, right? If we want this to be bigger or smaller. You can also add things like subtitles and captions to your plot, right? You could say like, I don't know, I'm just gonna say very cool plot for lack of anything better to say right now. And that'll give you your subtitle here. But basically like you can anything like you are wanting to tweak, you can tweak in pretty much any one of these little boxes. But basically like once you're like, yeah, I'm really happy with this plot, I think this plot looks great, you just click done. And it will automatically change the code for you. And then, except for I was not in the right place. I put it up there. That's not where I wanted it to go. Sorry about that. It should have put it in here. I guess my cursor was in the wrong place. That's cool. That's fine. Boop. There we go. Okay. It's supposed to be. Why is it not? There we go. It's being very weird about that. It's supposed to end up just like changing your code itself. But I think my cursor is in the wrong spot. There we go. Excellent. So now my cursor was in the right spot. So we see that it's changed some of our code for us. Our plot's not changed yet, but that's because we just have to hit play. And now we've got those things that we've changed in here. And like I said, if you're still like, okay, I want to change a little more, like we changed the background, which I liked, so you can go back up to theme assistant, and we can change that background fill to no fill. And of course, I again did it in the wrong place. That's fantastic. I love that for me. Ah! I need to very much make sure that that's in the right place. Excellent. Okay. Why is it putting it up there? That's really annoying. All right, that's fine. I'm just gonna add you here because you're being weird. All right. There we go. That gets rid of our background. Excellent. The other thing I do want to mention is there's another add-in that will actually make the entire ggplot basically point and click. It's another add-in. So if you go into the add-ins, there's another one that I've added in this space called ggplotbuilder. This is part of the Eskies package. Again, I've already installed it for you, but if you click on that, maybe. Oh, it might be because it's a pop-up. Okay, let's make sure this is all good. All right, you're done playing? Yes, you're done playing. Okay, cool. I'm gonna go somewhere else so it's not being weird. There we go. Excellent. Okay. So this Eskies is this basically like point and click interactive way to plot things. And I want to show this because, you know, even if, you know, coding is something you're still not super confident about, data viz is super, super important. So I want to show you this tool that'll basically like spit out code for you and you just click things. So first you just want to like make sure that you pick the right data set. So I'm going to just pick the original one. And then hit import data. And then it'll actually automatically populate all your variables here and you can actually just drop and drag them. So if I grab this and stick it in the X, I grab the weight, stick it in the Y, it'll automatically make a plot for me. And I can even say I want to color this based on sex. Boom, that looks great. I can also do some basic data filtering. So for instance, if I want to filter for just you know, the oldest students. So I can say, all right, I just want 17 and 18-year-olds, for instance. It'll automatically filter that. If I wanted to pick like a particular sexual identity or mental health, I could click on that and it'll filter that data for me. I can also do a bunch of like customization. So for instance, if I, you know, want to change any of the axis labels or titles, I can do that in here. If I want to change any of the coordinate systems, I can change that here. More importantly, I can also pick my colors here and my types of points. So for instance, if I want like, let's see, let's do like open squares. Why not? Sure. And then I can also make them a little bit bigger. And then I can also pick specific colors. So I can say I want my females to be like, no, I want purple. I really like purple. Pick purple for them. And then for males, I can say I want like this really fun, like dark green. Those are really ugly together, but let's say I like that. So then you've got all this stuff, right? So I've clicked my plot. I think it's like beautiful. I love it. If you click on code, it'll automatically generate the code for you. If my cursor was in the right place, I could also hit insert code script, but I don't think I actually put my cursor in the right place again. You can also like copy it, you know, hit copy to clipboard basically, and then go ahead and like pop this into like a new code chunk here. And then you've got that plot. So like this is another way to basically like make reproducible plots without actually having to do a lot of code. And the nice thing is like once you see the code here, you can kind of further tweak it, see what the structure is, kind of play around with it, and it makes it a lot more straightforward. So those were just like the two sort of interactive tools I wanted to demo because I do think that Getting held up by these nitty-gritty details and getting tripped up on code is like no fun way to do Viz. So these really are these nice companions that still give you code and you can still play with code, but you don't necessarily have to be as stressed about code. Any questions on those? All right, the only other thing I wanted to, oh, there's something in the chat. Hold on. Okay, cool. The only other thing I wanted to mention was bear in mind that right now you are in our workspace, and that will remain open through to the end of the hackathon. But after the hackathon, we will close down the entire Posit workspace, which means that anything that's in our workspace will get lost. So I do want you to be able to like keep the work that you do. So I do want to just point out how you can move your projects from our workspace to your workspace. So if you click on the workspace name, and then you see your project here, you see like next to it, there's a couple different icons. You can either make a copy, delete it, move it, or download it. So obviously like you could do both. You could click this export button and it will actually like zip all the stuff that we've done, like all the files that are in that space, anything you wrote out, any plots, all that stuff, it'll zip it all into one zip file and then download the whole shebang for you on your own computer. So that's one way to make sure that you have this work. You can hit download. The other thing is there's this, it literally looks like a little hand trolley or a hand moving cart. If you click on it and then select your workspace, it'll move over to your own workspace. So if I click on this over here, right, fair forward, this is the shared workspace. Like I said, it will disappear after the hackathon. Your workspace is yours forever, and it'll be there as long as you remember how to sign into your account. But yeah, that's the only other thing I wanted to share. Any
Cool. Um, just a few more things I think that I wanted to share before we close out, but I'm also watching the chat to see if there were any questions related to what Alyssa said. I just wanted to share this really cool resource called data2viz.com, built by this other really great data viz person in the R community in space called Jan Holtz. He sort of built this like exploration chart to like help you or help suggest the type of plot that you could be using, because people tend to use a bar plot for everything or a histogram for everything. And I can see the temptation to use it because it's just easier to explain to people, but some graphs are actually more intuitive the more you use it. So he sort of divides it into the types of variables, so numeric, categoric, both, or maps. If you're looking at data across time, or if you're looking at a network of data, and he further asks you whether your data is ordered. So if it follows a specific order, or if it's not ordered, and then he goes to give you examples of what type of data set, of what type of plot that you could use. And then if you click on one of it, so say we looked at scatter plot, he also gives you what the scatter plot is about, common mistakes when using the plot, but also code that you can copy and paste into your RStudio space. So he uses the ggplot package, which is fantastic, and gives you a gallery of examples that you can look at. So a basic scatter plot, and then the code is over here. And so he has an entire gallery of reproducible research. It falls right into our alley of the entire theme of our workshop in Hack Series, which is essentially working towards more reproducibility in open science and open research. So this is a fantastic resource. And I can also drop the link, which is data2viz.com, in the chat. I'm gonna hopefully copy paste that. Okay, Cool. Yeah, his work is super cool. He also has like a bunch of other stuff on his website if you ever are curious or you want to learn more about data viz. This is like easily my favorite part about programming, because it obviously looks really pretty and really cute. And it's very, very fun to do. So I will pause for questions that folks might have, but if not, or as we answer questions, if you're not on our Slack channel, please make sure you're on there. It is going to be super essential for the hackathon, but also for us to post any updates or announcements. Um, so ensure that you have joined us. That, and the second thing is ensure that you got an email from us to RSVP for the hackathon. And if you were registered, if you got a calendar invite to be on the Zoom link today, you should have received the email. Please check your spam junk folders because Gmail does that sometimes.
Just as a reminder, even if you already got the calendar invite, I still need you to fill out the Google form,
RSVP.
mostly because it also has a whole bunch of different projects. And that'll help me to make sure that you are in a project that you are interested in. So that gives us your interest in which project you end up being on a team for.
You definitely don't want to be stuck doing a project that you don't enjoy for the hackathon. Okay, I don't think we see any questions. So just before we close out, our hackathon dates are November 1st and 2nd. These core hours are in Eastern time, so 10:30 a.m. to 5:30 p.m. Alyssa, was there any more details you wanted to add about the hackathon itself?
No.
Okay, cool. Well, if you have any more questions, and you are welcome to ask them now, or if they come up later, you can drop them in the Slack channel or email us, whichever is easier for you.
All right, I'm gonna stop the recording.
Great. Thank you.